In this video, we're going to talk about the different types of data we have and the different levels of data. So first, we're going to talk about where the data comes from. So the first thing that someone collecting statistics needs to know is, what is their population? And what we mean by population is, who are you trying to learn about? This could be a relatively small group. It could just be the students in a particular class or a family, or it could be a really large group, like all the citizens of the United States, or potentially everybody in the world. So what we're going to talk about here, you need to know what your population is. So whatever your population is, if you collect data from every single person or object in the population, the data you get will be a parameter. So you have to conduct what's called a census to do this. You would have to, if you're taking a measurement, measure everybody in the population. If you're asking an opinion, you'd have to ask every single person. Now, most of the time, this isn't very feasible. It would be too hard to ask every single person or to measure every single person. So most of the time, we use a sample. When you get data from a sample, that's a statistic. So a parameter is when you've asked or measured everyone, and a statistic is when you've done a sample. Now, when we collect data that are numbers, so numerical data, we can have two different types. So the first type is discrete, and discrete numbers are numbers that can be counted. So we normally think of this as things that don't have parts or decimals or fractions. So for some examples, the number of children you have, right? You could say that you have 0 children or 2 children or 3 children, but you can't say that you have 2.5 kids. That doesn't make any sense. The number of cars in a parking lot. That's something you can count, and it's something that wouldn't have partial answers. The number of students in a class, how many stories a building has. These are all things that would be whole finite numbers. Okay. Continuous are numbers that could take on any range of values. And normally you want to think of things that are measured, things that can have those partial pieces. So numbers that can have any partial value. And normally you want to think of these as values that are measured. Where you could have 2.5 of something. So for example, we could talk about a temperature of something, right? So a temperature, you could have 98.6 degrees. We could talk about your height. So when we measure people's height, we don't say they're just 5 feet. We could say they're 5 feet 3 inches. You could talk about weight. Anything where it doesn't have to be those whole numbers. Okay. Now, the other way that we can kind of talk about categories of data are these 4 levels of data. And it really tells you how much information that data has, how much you can do mathematics with it, how much you can tell from that data. So our lowest level is nominal the nominal level. And that's data that can't be ordered. They're really just names or labels. You can think of categories. So for example, if you're collecting data, you're doing a survey, you could talk about someone's gender. That would just be a category, or their nationality. You could ask someone their favorite color. Now, these sometimes could take these could be numbers that you can't rank them. So for example, if you had a social security number, that would be a number, but you wouldn't say that one social security number is better than another. But most of the time we think of things that are names or labels. Now the next level is called the ordinal level. In this level we can rank things. So ordinal level can be put in order. But you can't tell the difference, tell how far apart two things are. So this is higher than nominal because you can rank them. So an example here would be if you have places of something. So if you're talking about first place, second place, so if you're ranking third place. So for example, if you were ranking colleges, you may have that Harvard's the best college, and then Princeton, and then, you know, another, say Yale, another college. But what those college rankings aren't telling you is how much better Harvard is than Princeton or whatever. You could also talk just about letter grades. So we know an A is better than a B is better than a C. But if you just are told that someone earns a B, you don't know how much better they did in the class than someone who earned a C. Okay. The next one is the interval level. In this one, here differences do make sense. But there's no natural zero. So there's no defined absolute starting point. So the two things that you're going to see in this class most often, examples, will be years and temperatures. So we know that 1995 is 5 years after 1990. We can tell how far apart those are. But we can't take ratios with them. We can't tell even more because the year 0 was not the beginning of time. Okay, so kind of same thing with temperatures. We know that 75 degrees is 5 degrees hotter than 70 degrees. But 30 degrees is not twice as hot as 15 degrees. So we can have negative temperatures. 0 degrees is not the coldest it can go, so it throws off ratios. Now ratios, this is the highest level. So these are going to be almost all measurements that you see. So here you have everything above. You can rank things. You can tell the differences between things. And there's a natural zero. So this is going to be almost anything that you can measure. That's not a year or a temperature. So for example, someone's height, someone's weight, salaries, if you were collecting data on how much people make. Any of those things are things that would fall into the ratio level. Okay, so here we have 3 different ways that we can kind of categorize data, whether it's a parameter or a statistic. That's one way that we can categorize data. We can talk about whether it's discrete data or continuous data. And then we have our 4 levels of measurements that tell us how much information the data can really tell us.